Hello, my name is Clemens. I'm the CTO of Persival, and today we're going to look a little bit deeper into how ASAM OpenMATERIal 3D works together with ASAM OpenSCENARIO and ASAM OSI. In the last video, I gave an overview of the geometry specification in the OpenMATERIal 3D standard, and today we're going to actually apply it. So let's have a look how these different standards play together. And for that, we start with OpenSCENARIO. That's the common truth definition. So that's where basically everything is defined that references all the other standards. So here we have an example of an OpenSCENARIO XML file. And in this file, you see the reference to a logic file. I showed you that in my introduction to the ASAM OpenX standards. Here we have a reference to an OpenDRIVE file. So there's a map behind this OpenSCENARIO. And what you also see is a so-called scene graph file. And that is a reference to an XOMA file. And XOMA is the file format for ASAM OpenMATERIal 3D assets. So that's a JSON file that's kind of the entry point of an asset. Every OpenMATERIal compliant asset comes with this XOMA file. And that's what's linked here. That's the stationary environment. So you, from the first couple of lines, you already know what's the map for the scenario and what does the stationary environment look like. What we also see then next is two scenario objects. And those are defined in a separate vehicle catalog. So let's jump into that. In the vehicle catalog, go back, you see here we have the vehicle example and the truck example. So we have to find them by name here. And that's those two here. So we have the vehicle example and we have the truck example. And they also have a reference to an XOMA file. It's called here model 3D. So not only the stationary environment, but also each individual moving entity in the scenario has a reference to an OpenMATERIal 3D asset file, and you can see that here. What you also have is definitions of bounding boxes, definitions of axles, like where they are, what the track width is, the wheel diameter of the wheels on that axle. That's all defined in the vehicle catalog, and that's all consistent with what's defined in the asset file. Let's actually jump to that so you get an idea what the asset file contains. This is an asset file of the vehicle example. You have a lot of metadata. I've gone through this in my general introduction video to OpenMATERIal. Check the link in the description if you haven't seen that. So I'm just skimming over this, but you have this is a vehicle, so a vehicle class specific data, and you can see the maximum speed, maximum acceleration, and also definitions of the axles that you will find also in the vehicle catalog. So that's the first reference. You have one OpenSCENARIO file and reference OpenDRIVE, and it references the OpenMATERIal 3D formats. And then, of course, it defines the scenario, so what should happen in that scenario. And now we're going to go to simulate that. We're using the AVL Scenario Simulator as a co-simulation platform here. You can use any simulation tool that supports these standards. Here we have ESMini as a scenario player. It's an open source scenario player that reads in an OpenSCENARIO file and plays it back. And we've connected to the output. So we have a OSI sensor view output, so ASAM OSI Open Simulation Interface standard. We output that and we put it into a scenario recorder. Don't worry about this bit here. We've actually also connected a sensor model here, but we'll go into that in a future video. For now, we just playback the scenario and record it as an OSI trace file. If you haven't seen the video about OSI trace files, I will also link that in the description, so feel free to watch that too. So now we just hit run. It's a very brief scenario, so it just runs one overtaking maneuver, and that's it, a couple of seconds. That's what's defined in the scenario. That was quite fast, right? But luckily we have OSI trace files, so we can replay that scenario and revisit what's going on there. So we go to runs here. We have this artifacts folder, and that's where the trace files are stored. They're stored in results scenario replay. And you see two trace files here. One's the sensor view, one's the sensor data coming out of the sensor model. As I said, we're going to look at that in a future video. So now we're going to open the sensor view. And in my last videos, I've always used the scenario replay that comes with the AVL scenario simulator. But today I'm going to replay it in a different tool. And that's our own Persival SimSpectre. Because the great thing about SimSpectre is it not only loads the information from the OSI trace file, like the bounding boxes of moving objects, it actually loads the referenced OpenMATERIAL 3D assets. So what I've shown you before, these references here to the stationary environment, but also to the individual vehicles, they are read in by the scenario player, in this case ES Mini, and they're propagated through to OSI. So there's in the Open Simulation Interface, there's a field called model reference. And this field is in the ground truth data for the stationary environment, but also for each individually moving object, and also individual stationary objects if you have that in the ground truth. And this enables a visualizer to load these individual models. And I'm going to show you that using SimSpectre. So I just double click here. I have SimSpectre installed, so I can just double click, and you see it loads the scenario. We have the stationary environment, and we have the truck, and we have the example vehicle you already know from the OpenMATERIAL 3D examples. And again, this is not SimSpectre, this tool here is not a simulator. It's a visualization and analysis tool. So I just opened an OSI trace file, and with it, and with the informations contained in that trace file, I have the entire 3D environment. And now I can replay that scenario. We have this overtaking maneuver, and you can see the eco vehicle, you can see the other object moving there. You can go back and forth, and you can watch that. There's a lot more features in SimSpectre. I will go into that in the future videos. The more features I describe about the standards and about the simulation itself, we will come back to that. So this is not the last time that you will see SimSpectre. In my next video, I'm going to go a little bit more into the details of the object class and object descriptions. For example, you already see here the wheels are rotating. The front wheels are moving depending on the steering motion. These kinds of things I talked about in the last video in the OpenMATERIAL specification. In the next video, I will go a little bit more into detail of how that works, how SimSpectre in this case knows how to rotate the wheels and how to turn it simply based on an OSI trace file. And that I will show you in the next video. If you have any questions, feel free to drop a comment below, and see you next time.